All right. We'll get started here. I think Brett went back to uh, site B, so I'll send him a message real quick. Let him know that we were in C. All right. Any questions about significant figures?
No.
Okay. That seems to be like sig figs seem to be one of the things that really kind of jam people up. And it's just something that we'll kind of have to work through as we go. And so, if you're unsure about how or what I'm doing or how things are going, just stop me and ask a question. We can fix it from there. But let's go ahead and do a couple of examples of some problems here. So the speed limit on I-70 between Denver and Kansas City is 75 miles an hour for most of the distance. How many hours will it take to travel the 604.9 miles between those cities? For the purposes of this problem, we're going to ignore all stops. We're going to ignore changes in speed limit. We're just going to assume that you're going to go 75 miles an hour the entire time, the entire way. So from that standpoint, what we need to do is we're doing a conversion here. Ultimately, what we're doing is we're going from miles all the way to hours. Now, the conversion factor that we have for this is our speed, 75 miles per hour. Remember that the word per indicates a division, a ratio, a fraction of some sort is taking place. And so from that perspective, we can say that 75 miles per hour means that 75 miles are equal to 1 hour of time. And so if that is the case, then what we can do is we can set up our conversion problem where we've got our distance 604.9 miles. And what we're going to do is we're going to multiply that by a series of factors, a series of conversions to get rid of the miles and turn it into hours. And so our first and only factor here, 1 hour is equal to 75 miles. And so if we take that 604.9 miles and divide it by 75 miles in 1 hour, what you would get is that we can see that our miles in our numerator cancels out with the miles in our denominator there. And if you plug that into your calculator gives you something like this. Which obviously is way too many. So the question is, how many significant figures do I need to round to here?
4.
All right, who said 4?
Me.
Oh,
Lost.
Malaz. Okay. Why do you think 4?
Because the 75 is definite and yeah.
Okay. Interesting subpoint here. Is 75 miles an hour a measured value or an exact value?
That's an exact.
So you're telling me that when you drive in your car and it says that it's 65 miles an hour, that it's exactly 65 miles per hour, 65.0000000.
No.
It's a measurement. It's an
Okay.
instrument.
Okay.
Your speedometer is an instrument. It makes guesses. If it says 65 miles an hour, it's probably somewhere between 64.8 and 65.2. It's an estimate. So if we're telling you that it's 75, this is a measured value here. And so since both of our values in the conversion here are measured, we need to consider the significant figures of the conversion factor as well. So there are only 2 significant figures, not 4.
Okay, because I was taught differently, so I have to get out of that habit.
Okay, how were you taught?
That anytime you see anything with a decimal, you usually just go ahead and do that, because if it's given to you, then you ignore those sig figs, but the one that's like that has a decimal is the one that you use. That's how I've been taught, so now I have to break the habit.
Yeah, so that's not a bad rule of thumb, but honestly, anything that is measured has uncertainty to it. And that's really the approach that we need to take here. So we're going to round this. It'll be 8.1 hours.
Quick
So,
question.
Go ahead, Brett.
Isn't time technically measured as well, though?
Well, in a sense it is, but it's already been accounted for in the 75.
Oh, okay.
When you have a measurement like that, the division's already been done. So we can assume that whatever sig figs were rolled into the hour have already been accounted for in the measurement of 75.
Okay.
So yeah, technically true. You know, time is not an exact value either, unless we're talking about things that are defined values. You know, there are exactly 60 minutes in an hour. That is a defined value.
Yeah.
There are exactly 60 seconds in a minute. That's a defined value. That has infinite precision. We don't use the sig figs in those.
Okay.
But if we're talking about a measurement of speed, if we're talking about a measurement of acceleration, if we're talking about a measurement of mass, any kind of measurement in that regard, if we're talking about, you know, Usain Bolt, running the 100-meter dash, that time is a measured value. It's not an exact.
Okay, I got you.
All right. Any other questions on this example?
Nope.
No.
All right, let's look at another one. Okay, we've got fuel economy. Fuel economy relates the distance a car can travel on a set amount of fuel. If a car has a rating of 41.7 miles per gallon, what will this be in kilometers per liter? So this one's a little bit different in terms of the way that we set it up, because 41.7 miles per gallon, again, there's that P, there's that per, What we're talking about is we've got a measurement of 41.7 miles divided by 1 gallon of fuel. And so from that perspective, that's what we're starting with. This is a combination unit. So we're actually going to be doing 2 unit conversions simultaneously. We need to convert the miles into kilometers. And we need to convert the gallons into liters. Now, we can flip back and find the conversions that we're needing here. So miles to kilometers, 1 mile is 1.609 kilometers. And then gallons to liters, if we go to volume here, 1 gallon is equal to 3.785 liters. So if we go in this direction, then it doesn't really matter what order we attack them, but we're going to need 2 different conversion steps here to get to where we want to go. We just got to make sure that we put the right things in the right places. So let's do the distance first. We had miles and we want kilometers. So 1 mile is equal to 1.609 kilometers. Now we set it up this way so that the miles in the numerator here cancel with the miles in the denominator there. We're left with the kilometers that we wanted. For the gallons to liters, we had 1 gallon, and that is equivalent to 3.785 liters. And again, we wanted to make sure that the gallons canceled. So I had gallons in the denominator here. I want to make sure it was in the numerator there, so they canceled.
Okay, Mr. Brown.
Go ahead, Chassie.
Okay. I thought that you feed off of one another. Wait. Never mind. Okay. Like.
Go ahead.
Okay.
Explain your question.
It already canceled because I thought you fed off of one another. To where the slashes will line up, but.
Well, you want the slashes to be opposite each other.
Right. So maybe I'm tripping. Okay. I think, go ahead.
So
I'm just seeing it like where the 1.609 is, it cancels with something at the bottom.
It shouldn't. There are, so if we look at the units that we have, I have miles in the numerator, kilometers and gallons. I have gallons, miles, and liters. So I have kilometers that doesn't cancel. I have liters that doesn't cancel.
Okay.
Now, if I had flipped this one around,
yeah,
then what I would have had was I would have had kilometers and liters in the numerator, and I would have had gallons times gallons in the denominator.
Okay. Yep.
So
okay.
think about each of these things. They each multiply 1, 2, 3.
Okay.
And so every fraction multiplies with the fraction next to it.
Okay.
And so the literal way that we can do this is we can multiply all of the values on the top we can divide all of the values on the bottom. And when that's done, all of the units kind of go along for the ride. So let's just, as an illustration here, let's go ahead and complete this problem.
Okay.
So if I did it, so 41.7 multiplied by 1.609 divided by 3.785. Now the number I get here is 17.7266 and then a bunch of other stuff. How many digits actually matter here? How many do I need to round to?
Either 1 or 3, but I think 3 would make more sense, but I don't know.
It would be 3.
Yeah.
So for these ones where we have 1 gallon, 1 mile, we can assume that that one is exact, that the measurement is, I took a gallon of water and I poured it into a graduated cylinder and measured how many liters it took up. So the 1 is exact. The 3.785 is measured.
Okay.
The 1 mile is exact, but the 1.609 kilometers is measured. So in these kinds of conversions, if there's a 1, we can assume the 1 is exact. The other value is the one that we'd have to worry about. So 3 significant figures is our answer here, because our starting measurement, 41.7 miles per gallon, that has 3 significant figures. So in the end, 17.7 is our number. Now, if I look at the units, I had miles times kilometers times gallons divided by gallons times miles times liters. And so I can see that after I've done my multiplication, I've got miles in the numerator and the denominator. They're going to cancel out. I've got gallons in the numerator and the denominator. They're going to cancel out. And so in the end, all I have left are the kilometers divided by the liters. And so when we use this dimensional analysis technique, that's how we go about it. That's how we do it. Multiply by everything on the top, divide by everything on the bottom, and see where that takes us. All right. Other questions on this problem?
No.
All right, let's take a look at another one. A 1960 silver quarter is found to have a mass of 6.25 grams. On a given day, the value of silver is $17.32 per ounce. How much is the coin worth if the coin is 92% silver? All right, now I've got a question for you guys. Are you able to annotate? Are you able to write on this?
Writing on paper, but
Oh, you mean right on the Zoom?
Yes.
I don't think we can.
I just have reactions, record, share screen, chat, and participants. That's all
Okay.
I think.
Well, it claims that you're able to, but if you can't, that's no big deal. We'll just go through this together. What I was going to have you do is, if you had the capability of writing on, there we go, Chasney's on.
oh, you have to request, go up to view options and request remote control from Mr. Bro.
Oh, okay. Oh, I see.
All right, hold on.
Annotate. We can annotate.
Yeah. Okay. Okay. So Chasney, you've got it right now.
Oh, okay. I can't see nothing, but it says end of slide.
Oh,
Yeah.
oh, how about that?
Oh.
Yeah.
How about that?
Yeah, I can see now.
Yeah. Oh, you want me to start? No.
Okay. All right. Well, what I was going to do is, if you were capable, I was going to kind of split it up, and anybody who wanted to try to write their stuff down could, and we just kind of go through it together.
Oh, okay.
So if you're comfortable, trying this out on your own, if not, we can.
Because I have to flip back to the slide with the conversion. That's
Okay.
why.
Okay. All right. Well, maybe we'll try this again a different time. Let's go. So what we have here is we have a 6.25 gram quarter.
Mm-hmm.
And we also know, if we go back, that that 1 ounce is 28.35 grams. And so
Yeah, that's the slide I needed, Mr. Brooke.
Okay.
In order to do it.
Okay. There. Okay, that was the conversion you needed.
Yes. I need to go. Well, you want me to go back, or you going back? I need it for the ounce. I need to convert the ounces. How much is? Can y'all all hear me? Are we all talking and he's muted?
No, everybody's on.
Oh.
Everybody's on.
Okay, we doing it right. The student. I mean.
Yeah. So I've given you the conversion factor there.
Yeah.
Okay. So what does this tell you?
So what that does is it converts from grams to ounces. So we would need to cancel out the grams and divide it by 28.35. And then we'll have our ounces. And it says that it is 92% silver. So multiply that by 92 and then multiply that by 17.32.
Okay. I don't know if it's letting me click it. It's not letting me. So I thought I had control, but I guess I don't. No, it's not letting me.
Okay. We can try this again tomorrow, maybe, or another time. Okay. Following the direction that Brett had us going, we can approach this one of two ways. It really doesn't matter which. But one of the directions that we can go is, we know that every ounce is worth
$17.32.
$32, exactly. Okay, now if we stop the calculation here and did an equals 6.25 multiplied by 17.32 divided by 28.35, what we would get is essentially $3.82.
Mhm.
Now, that would be correct if the entire mass of the quarter was all silver, but it's not. Some of it is some other stuff. It's only 92% silver. So the last step in here is we got to multiply this number by 92%, which would be 0.92. And if we did that, we'd end up getting $3.51 instead. So you could have approached this in a number of different ways. You could have applied the 92% to the initial mass. So instead of doing this step here, you could have done it here or here. But this was the set of steps that you needed to do. You needed to convert the mass. You needed to take that mass and convert it into money using the exchange rate. And then you also needed to apply the fact that the coin was impure. And those are the three things that you needed to do. All right. Any questions on this one?
No.
Mm-mm.
No.
Okay, so this one's not in your slides, but it is something I want to do because it's a very common question. And so hopefully you can all see this now. You guys see the whiteboard?
Yeah.
Okay, so all I want to do is just a real quick problem. All right. Can we convert squared or cubic units?
Yes.
Now the question is, how do we do it? Because if I go to that conversion table, what you're going to find is that these kinds of units aren't there. And even if I did it volumetrically, if I had a cubic unit, some cubic units are in that volume chart, some are not. So how do I approach problems like this, where I have to convert squared units to other squared units?
It's basically just the same approach. So what you would do is you'd have your 39.99 feet squared, and then you basically have that, and then then on the conversion would be 144 inches squared over 1 foot squared.
Okay. So yes, you are correct. That is how you would do it. Now, to those of us that don't do that in our head, where did the 144 come from?
It's 12 times 12.
Okay, so that's the important thing there is if you're dealing with a squared unit or a cube unit and you don't have the conversion directly, you can always use an indirect conversion. And the indirect conversion is just using that calculation, that conversion that you know, however many times are in that exponent. So I know that 1 foot is equal to 12 inches. That is the world's worst looking 12. Okay, I know that this conversion is accurate. Now to convert it to square feet or to cubic feet. I just need to apply that calculation however many times. So I either can square the conversion and think about it that way. And if I do that, then that's where we get Brett's 144, because that's 12 times 12. Or I can literally write it out twice. Where I just have to do that particular one 2 times. And so either way that I do it is accurate, is correct. And so if I do that, I've got feet times feet in the denominator. That cancels out the feet squared in the numerator. 39.99 multiplied by 12 squared, or 12 times 12, to 4 significant figures is 5759 inches squared. So if you come across these kinds of things either in the homework or in the unit conversion post lecture, if you don't know the conversion directly, you can always do it indirectly by using a conversion that you do know, and then just squaring that conversion or cubing that conversion depending upon what the unit is. Right. Any questions there?
No.
Okay, so we're pretty much at the end of our lecture time for today. That pretty much concludes chapter 1 for us. And so my encouragement to you, you've got a couple of post lectures that are due tonight. I would encourage you to start working on that chapter 1 homework as well, because there is a chapter 1 quiz coming up. I believe it's Tuesday in Blackboard. In the meantime, as far as lab is concerned, go ahead and start working on those dry labs. I went ahead and uploaded, I think it's the first 6 activities into Gradescope and into Blackboard. So once you get your lab kit, you can do some of those. But right now, the lab safety, which I see that I think most of you have done, that's up there. The 2 graphing activities, those are up there as well. So you can at least get a jump start on those while you wait for your lab kit to come in the mail. All right, any questions?
No.
All right, so I will have an office hour at 1 o'clock today in Blackboard. If you have any questions that come up, otherwise I'll see you tomorrow morning at 9.
Okay, thanks.
Thank you. Bye-bye.
All right, bye.